Why is the quantum world important for us? Quantum mechanics began as a construction or a series of theories that people developed to try to explain experimental results, namely to understand why it is that there were photon lines that you could see in very discrete energy levels. And this notion that the energy would come in discrete lumps was a key component to the early development of quantum mechanics. You might ask, why is the quantum world so different than the world which we inhabit? One of the things that we've realized over the past century is that as we go to smaller and smaller scales, the nature of how particles behave is very, very different from how it behaves in the world that we sort of know and inhabit. One of the easiest ways of trying to understand the paradoxes of the quantum world is what's known as the Double Slit Experiment. In this experiment, there is one hole where particles will pass through. There's two holes that then you allow the particles to pass through again, and then a screen on the other end where you look for what is the pattern that you see from this whole experiment. If you do this with rocks, maybe pebbles, maybe sand, and you fire this through the initial slit, then allow them to go through the next two slits, they will end up with a pattern where the largest number of hits you'll get will be directly behind the two holes of the slit. If you do this with water waves, you'll find that the water waves will come through the first slit, create a wonderful wave pattern that will then spread out, and then as the water waves go through the subsequent two slits, they can come together and interfere, generating a wonderful interference pattern, making you think, the electron is a wave, it behaves like a wave. And yet, when you look individually for when electrons actually hit the screen, they hit in discrete lumps. So, boom, boom. But they build up an interference pattern as you proceed with the experiment. If you then create some sort of detector, something to tell you that the electron went through one or the other slit, it ends up accumulating exactly as if it were a classical object, or rocks or sand. If you stop looking, it goes back to the interference pattern. The really bizarre part of the quantum world is that if you look, if you try to ferret out what's really going on, you change the result on the other end.